In this video I'm going to look at some examples dealing with the measures of the arcs on the circle and the measures of the central angles. So my first one, I want to calculate the measure of arc QR. Now I like to highlight this just so that I know which one I'm working with. So arc QR, that would be this arc right here. And for some reason it likes to straighten it out on me. That arc right there. Now what I want to look at is maybe it's easier for me to calculate the measure of that angle. Because remember, the measure of the central angle and the measure of its intercepted arc are always going to be equal. So I'm going to look at trying to find the measure of angle QTR. To do that, I'm going to need to be able to figure out what is x first. And the first thing I look at is these three angles together. I know those three together are going to add up to 180 degrees. So I'm going to write my equation that says that. There's the first angle, second angle, and my third angle. And I said they all have to add up to 180 degrees. Well, now it's just a matter of solving my equation. Now the first thing that I'm going to do is I am going to add 2 to both sides. And the reason that I'm adding 2 to both sides is because the -4, the -3, and the +5 would all together equal -2. So if I add 2, that'll get rid of that. Now I'm left with 8x, 13x, and 5x for a total of 26x equal to 182. Next, I'm going to need to divide both sides by 26. And I'm going to find that my value of x is 7. Now that I know the value of x, I can come back up here, and I'm going to put it right here into this angle, 20 times my 7. Therefore, I know the measure of this angle is 140 degrees. And that's helpful because now these two angles together are going to have to add up to be 180 degrees. Well, if one of them is 140, I can pretty quickly find the measure of the other one by subtracting. And I'm going to find out that the measure of that angle is 40 degrees. So if this angle is 40 degrees here, that means the measure of arc QR is also 40 degrees. I have solved my problem. Now my next one, I give you some information, and I want to find the measure of 3 different arcs. But before I get going, I want to go through and I want to mark up my picture because I think that's very important. So the first one it tells me that segment PL bisects angle KPM. Well, segment PL, I see that, and angle QPM. Well, if it's bisecting, it's telling me that these two angles are going to have to be congruent. I also know that segment OP and segment KN are perpendicular, and that's already been marked right there. So I don't really need to do anything with that. And now I can go through this and I can figure out some angle measures. So I want to find the measure of arc OK. So let's go like this. Let's go with the light one. So arc OK is going to be this arc right here. Kind of light, so let me just make that one right there. So if I could find the measure of these two angles, whoops, I would be able to know the measure of arc OK. What I'm going to do this is, get rid of that. The first thing I'm going to look at is this 46-degree angle. I see that it's a vertical angle with this one right here. Probably do double arc. So I know this is a 46-degree angle. And then I also know that this is a right angle. So I can do the 90 minus 46. And my answer is going to be, oops, not 54. No typo there. Be 44 degrees. Which tells me, well, I guess I didn't need to do all that. The measure of the yellow arc that I have marked there is going to be 90 degrees because the measure of the central angle that created it is 90 degrees. Now the next one I have is arc LM, which is going to be this arc. Now I'm going to need to calculate the measure of angle LPM so that can figure out the measure of arc LM. Well, now when I look at this one, I know these three angles together are going to have to add up to 180 degrees. So what I can do is I can take 180 and subtract 46 degrees, which is one of them. And that's going to give me the measure of those two green angles together. And I'm going to end up with 134 degrees. But now each of those angles are congruent, so if I take the 134, cut it in half, I find out that I get a measure of 67 degrees for the measure of this angle, which means this one's also 67 degrees, which then means the arc is also 67 degrees. And then I have one last arc to calculate the measure of. And that would be arc JKO. So I'm going to start at J, and I have to go all the way around my circle until I get to O. So I have a major arc here. Then I'm going to try to calculate the measure of. Well, I'm going to look at this. I've already found the measure of this angle here was 44 degrees, which means arc JO is 44 degrees. So for me to calculate the measure of arc JKO, I can just take the 360, which is all the way around the circle, subtract the 44, and I end up with 316 degrees for the measure of arc JKO. For a problem like this, it's a matter of just marking it up, calculating the measures of smaller angles, smaller arcs, and then putting all the pieces together. Now on this one, notice this one wants length. I want the length of an arc, so I want arc length. And this one, go back to that little formula that I gave you in your circle book. Now if we look at arc MO, that's this arc right here. Well, the measure of that arc is going to be the 90 plus the 46, which puts us at 136 degrees. That's the measure of the central angle, which means it's also the measure of my arc. Now, go back to that little formula. It said if I took the measure of the arc in the numerator, divided it by 360, well, I can put this in because I know the measure of the arc is 136 degrees. And it's going to equal then the length of the arc, which I'm just going to call x because I don't know it, divided by the circumference. Well, circumference, I have that circumference formula, which is equal to 2 times pi times r. So 2 times pi, and it says that my radius here is 7 inches. So I have everything that I need to know to calculate the length of this arc. Now it's just a matter of solving my proportion. So I'm going to start off by cross-multiplying. Sorry about the little pop-up. That's gone. Now let me finish solving this. So 360 times x, and then equals, now I'm going to multiply this way. I'm going to end up with 1,904 pi. Now notice I didn't put the pi, the approximation, in there yet. I'm just going to leave it like this. I'm going to find the exact length to start, and then I'll show you the approximate after that. So the next thing to do would be to divide by 360 on both sides of my equation. And I find out that x is going to equal, now I've simplified this fraction, I'm going to come up with 238 over 45 pi, and that would be inches. So the exact length of my arc is right here as you see it. Now, the approximate value is 16.62 inches. That one probably makes a little bit more sense in this case. We could actually see or kind of know how big it is versus this number here is a little hard to comprehend how big it is. So by using our little arc length formula, we can calculate the length of any arc, as long as we know the circumference and the measure of our arc that created the angle. Now, this will be my last example. And on this one, notice now I want to find the length of arc, or actually in this one I want to find the length of the radius, and I know the length of the arc. So I'm going to just highlight the arc that I know the length of. So it's arc JL. So I know that this length right here is the 19.01. Now remember from previous problem, this is the same circle. I'd already calculated this is 67 degrees, this is 67 degrees. We had also said that this was a 46-degree angle here because of the vertical angles. So with that in mind, I know then the measure of this angle by taking my 46 and my 67 and adding them together and getting 113 degrees. So now I know the measure of the arc. I know the length of the arc. The only thing that I don't know is this, essentially the circumference when I come back to my formula for arc length. And the reason I think arc length formula is because it tells me the length of the arc. So then it's going to be my 113 divided by the total, which is 360 degrees, equals, well then the arc length, I know that, it tells it to me right here. That's the 19.01, so there's the part, over then the whole, which is the circumference. Now remember, circumference is 2 times pi times r. That's one way to calculate it. And I'm going to go with that because I'm looking for the length of the radius. So now I have an equation, I just need to solve it. So I'm going to cross multiply. First I'm going to go like this, take 360 times the 19.09, and I end up with 6,843.6 equal to, and now I'm going to cross multiply this way. And being I'm dealing with decimals already, I'm going to put the 3.1415 so on in for the pi when I do my multiplication here. And I end up with, it would be approximately 709.99, so I'm going to go 710.0. And I use the pi button on my calculator and then r. Well, now I need to divide by 710.0, and I'm going to use the number that I still have in my calculator to do this. And I should have the value of my radius. I come up with a radius length, and this would be approximately 9.64. And then all I need to do is put the label on it. So I'm going to come back up here. Notice it was talking in terms of centimeters. So then the radius is also going to be in terms of centimeters. And that's going to conclude the lesson portion on arcs and angles, or angles and arcs, inside and on circles.